Coming to question number 3, says the switch is closed assuming all initial conditions as 0. Find I di by dt and d square I by dt square at t is equal to 0 plus. Have R L C supply voltage, the switch 10 volts, 10 ohms, 10 Henry, 1 microfarad. I of t. We need to find I di by dt, d square I by dt square. Question tells that the switch is closed initially, assuming all initial conditions to be 0. That means we'll write all the initial conditions at t is equal to 0 minus. We need to find the current through the inductor, which is nothing but I of t, and voltage across the capacitor. Since all the initial conditions are 0, voltage across the capacitor will be 0, and current I of t at 0 minus will also be 0. Now I'll go for t is equal to 0 plus. We'll replace inductor with the current source, but since the current is 0, we'll replace it with open circuit. Capacitor voltage 0 will replace with short circuit. Since this is open, no current will flow at t is equal to 0 plus. How the circuit will look like at t is equal to 0 plus? The switch is closed, have the resistor, inductor is open circuited. Since the initial current is 0, capacitor will be shorted, and you have the voltage source. This is how the circuit look like. 10 volts, 10 ohms, and I of t. But since this is open circuit, current at 0 plus will be 0. Voltage across capacitor at 0 plus is again 0. Now we'll go for t greater than 0. So for t greater than 0, we'll apply KVL. So the circuit for t greater than 0 will be 10 ohms, inductor as it is, capacitor as it is, and the supply voltage as it is. 10 Henry, 1 microfarad, 10 volts, I of t. So applying KVL, it will give me 10 minus 10 I of t minus 10 di by dt minus 1 upon 1 into 10 raised to minus 6 integral 0 to t I dt equals to 0. Now I can write it as 10 is equal to 10 I of t plus 10 di by dt plus 10 raised to 6 integral 0 to t I dt, calling this as equation number 1. At t is equal to 0 plus, since this is the same limit So area of integration we don't have in this, so this part will become 0 at t is equal to 0 plus. So you can say 10 is equal to 10 into I of t at 0 plus is 0 di by dt as it is dy dt I at 0 plus. So from this you can find di by dt at 0 plus will be 1 amperes per second. So we have found I at 0 plus, we have found di by dt at 0 plus. Now we can find d square I. So I will differentiate equation 1 with respect to t. So it will give me 0 10 di by dt plus 10 d square I by dt square plus 10 raised to 6 I. Then at t is equal to 0 plus, this term is 0, so we are left with only these two terms. We can say d square I by dt square is equal to minus d by dt, this is at 0 plus, di at 0 plus, so I can say this is nothing but minus 1 ampere per second. So I can say d square I by dt square at 0 plus is minus 1 amperes per second square. So this is how we have found all the values which were asked in the question.